Okay. Now in this part of the lecture, we are just going to start coding some basic functions for a linked list. And while going through this, we will be switching from the laptop to the document camera whenever needed. If we need to understand something diagrammatically, we will be switching to the document camera. Else we will be just looking at the code. Okay. So I'm going to create a file called linked list. Okay. And here let's first start with a struct node. We have the data part, and then we have the pointer to a struct node called next. Okay, this is our structure of a linked list. I'm creating it. I'm defining the structure outside all the functions. Okay, and so I'm writing my main function. Okay, so now inside main, as we just did, let's just try creating let's just have a pointer to a struct node. And one of the questions during the break was like, why do we create a pointer to a struct node instead of a struct node itself? Okay, and one of the main reasons is whenever we deal with larger data structures, like if usually structs will have like nearly 100 like elements in the real world. If you look at some operating system code, there is a struct called the process control block, which has like a numerous data associated with it. And usually C structs are like large enough. Whenever some structs are large enough, if you are creating a normal variable, structure variable, and if you are passing that structure variable to different functions, those variables internally will be copied in memory. If you're passing some variable from main to, let's say, some function, you're copying those variables values from main to be local within that function. And if the structures are larger, and then what is happening internally is like unnecessary copying of data is happening. To avoid that, we usually pass structures using pointers. The structure remains the same. You just pass a pointer to the structure. That particular function operates with the same structure. The structure is just present at one region in memory. And then once that function is done, again, there is like no copying of data that is happening between functions. You can think of this as if we have a Word document, and if we are like sending it to multiple people, and each of us, if we are attaching the same document by updating that, okay, opposed to having a single document on Google Drive and everyone just dealing with the same document. You can just think of pointers to structures, something like that. So we have this null, and let's assume now while we are writing code here, we are not going to just create the first element and things like that. We will be creating like some functions. We'll be writing some functions, let's say, to add elements to this linked list. So in this case, first let's just start with a function called insert. If you want to like do something useful with the linked list, first we should add some elements to the linked list. Okay, so we are trying to add some element to the linked list, and we are going to insert the elements at the end of the linked list. Okay, and now the name of the function, I have just decided that it is going to be insert at end. Whenever we are writing functions, we have to decide the prototype or the signature of the function. We have to decide what are the inputs that this function is going to take, and what are the outputs that this function is going to produce, what type of outputs. And at this point, let's assume that since we are going to like make some modifications to some list, this function should know which list should we modify, or to which list should I add some data at the end. Okay, and in this case, it's going to be, let's assume this is the only way that we can access that linked list that we have, which is null. As of now, the linked list is not even created. And so we are just saying struct node star. This is going to take some head of the linked list, okay? Again, remember, this is a local variable, okay? This is a local variable within that function. It's going to take some pointer to some struct node, okay? And along with that, it's going to take, if you want to insert something, you need some data to be inserted. So we just say, I want to like some int data to be inserted. Whatever we just wrote now is called a function prototype in C. This just informs the compiler that some function like this is going to come at the end, because usually when we write main here, and if we write the same function here, and we also should decide the return type. Let's think about the return type. What should insert at end function return? If I had started this, I wouldn't have been sure about this. So if I'm not sure about something, maybe I can just have it as void, okay? Then later when we decide something, we can change it, okay? So let's just start it with void, and then if you want to then we need to just write a definition for this particular function, insert at end. So in this case, definitions start with this. So we are going to define this function, and we are going to use this function somewhere here. And what should we pass to this function? It takes in a pointer to a struct node. So head is already a pointer to a struct node. And then along with that, it takes in some data. So let's assume the first data that we are going to insert in this linked list is just a value of 10. Okay. Then now we are inside the insert at end function. When we want to like insert, so this function, we are assuming that inserts the elements only at the end of the linked list. So initially if we add 10, that's the first element. Then if we add 20, the linked list is going to be 10, 20. And if we add 30, it's going to be 10, 20, and 30, and so on. So in this case, now you got some data. You also have some head of a linked list to which you should insert into. Now let's see what should we do, okay? The first thing that I would do is like struct node. I'm just creating a variable called current, okay? A pointer called current, and it is a pointer to a struct node. I want to keep track of where am I in the linked list, okay? To go to the end of the linked list and insert some element there. I'm just assigning this to the value of head. Head is the first element in the linked list, or address of the first element in the linked list. I'm assigning this value to current. So I'm thinking, okay, I'll start with the first element, okay? I want to go till the end and then insert an element there, okay? Okay, so before we go to the end, first let's just create that new node that we are going to insert, okay? Create a new node. In this case, as we know, like if you want to create a new node, you're going to use malloc size of struct node. This will create you a node, and you need to like get that value in some pointer so that you can access that. And maybe I will just name it as new node. And this is of new node is again just a type pointer to, it is just a pointer to a struct node, because malloc returns a pointer. It's just an address. You store that address in a new node, and so the type of the new node is nothing but struct node star. And since malloc returns a void star pointer, you can store that address in basically any type of pointer. And in this case, you're storing it in a struct node star, pointer to a struct node. Then we can just like make this, the data part of this new node to be the data that we just got here, the data that we just have here. I'm assigning it to the data part of the new node. And since we are adding nodes only at the end of the linked list, the next part of the nodes, of this new node, of all new nodes, are going to be just null, because that is going to be the last element in the linked list. So we just created a node on the heap, and we have a pointer to that new node using a variable called new node. Now, after this, okay, we want to like iterate to the end of the list. And to do that, we say while so whenever we do things like this, okay, first let's do the common case, okay. In the common case is like, let's assume there are some elements already in the linked list, okay, and we are inserting some element here. So while current dot next. So if current is the first element, current dot next is the next pointer in the first element, or the address of the second element. Okay. If current dot next, you can just leave it as it is, or you can even say like if current dot next is not equal to null. Both means the same in the sense you can have this condition as, all I'm saying is if there is some element, if there is some next element in the linked list, do something, okay? So I can have the condition as current dot next is not equal to null. It's just a programming style, or you can just make it as just current dot next, because it also evaluates to the same thing. It just evaluates current dot next. If it is null, the value of 0 comes here. If it is not null, some other value comes here. And in C, as we saw previously, the value of a Boolean expression, if it is 0, it is false. If it is anything else, if it is non-zero, it's going to be true. Okay, so that is the thing that we are applying here. So for simplicity, I'm just having it in the detailed form, okay? While current dot next is not equal to null, just missed this. Okay, just move current to the next node. Okay, I'm moving current to the next node, current to point to the next node. Okay,